All right, and we're live. Let me go ahead and go over here. Welcome to the GraphQL Meetup. We are currently live. We are here with Yves Porcello and William Leon, and we're pretty excited for today's meetup. Let's go ahead and, before I get started talking about the few things I want to talk about, I would like to introduce you to William. Is it Leon or Lion? I'm sorry.
Lion, like the
Lion.
animal. Rawr.
Yeah, William Lion. Yeah. Sorry, I took too much French in high school and I was bad at it. So
it's the Scottish. It's the Scottish version, not the French version.
Yeah. So Scottish, cool. William Lion. So yeah, if you want to tell us a little bit just about yourself, before we get started, I'll give you an introduction. We're just kind of letting some people come on, and while we still chit chat for a little bit.
Yeah, so I work for a database company called Neo4j, which is a graph database. I work on a team that we call Neo4j Labs, which builds plugins and extensions for Neo4j. So try to enable developers to use Neo4j with different technologies, different frameworks, solve their graph problems. And my focus for the last little bit has been working on our GraphQL integration, which is what I'm going to talk about today.
Sweet. Well, we're excited about it. Before we talk about the GraphQL integration, we have to talk about that tree in your background, because it's really awesome.
Thanks. Yeah, I needed a little bit of Christmas cheer in the office, so we set that up a few days ago.
Yeah, sweet.
I don't know if you can see this, but I didn't have a lot of ornaments, so I took some work stickers and made them into ornaments.
Yeah.
Oh, nice.
I love the tree. Oh, wow. We have a whole bag of conference stickers. I never even thought about doing that.
That's genius.
Using them for ornaments, because they're
yeah, just put a little wire through them and they hang up pretty nicely.
Yeah. All right. Well, I think we have some viewers on, so I'm going to go ahead and just get us officially started here. Welcome to the GraphQL Meetup. I am Alex Banks. You can find me at Moon Tahoe. I co-host this meetup with my partner and wife, Yves Porcello. You can find her at Yves Porcello on Twitter. We host this meetup in associations with This.Labs, which is a software engineering consultancy. And today, we have William Lion with us. And if you were just here for a second ago, you heard that William works at Neo4j. And we're really excited to hear about what he's going to be talking about today. So without further ado, I'm going to go ahead and just change the screen to William's screen. And yeah, whenever you're ready, William, we can go ahead and get started.
Okay, great. Well, thanks for organizing, and thanks for having me on. The title for my talk is Low Code GraphQL with Neo4j. You can find the slides at that link on the screen there. My Twitter handle is also linked there, which is a good way to get a hold of me if you have any questions or thoughts. So here's kind of a rough agenda of what I'd like to talk about. I want to give just a brief kind of overview of what Neo4j is and graph databases in general, but talk more about why it makes sense to use GraphQL with Neo4j, and then focus on how we can build GraphQL APIs with Neo4j. Take a look at some of the tooling that we've built to make building GraphQL APIs with Neo4j a bit more straightforward. And then also kind of a look behind the scenes at how we build some of those tools. So that is the plan. So like I said, my name's Will. I work at Neo4j on what we call the Neo4j Labs team, which is focused on building plugins, integrations, extensions with Neo4j and other technologies. So I don't work on the core database itself. Instead, I work on tooling and integrations around the database. I recently just started a newsletter also that just kind of share what I've been working on and interesting things I've seen online, which is linked there at my personal website /newsletter. So if you want to keep up with what I'm working on, that's a good way to do it too. I've also been writing a book published by Manning called Full Stack GraphQL Applications with GrandStack. GrandStack is GraphQL, React, Apollo, and Neo4j database, which we'll talk about a little bit later. This book, though, is a good overview of how to use GraphQL with these different technologies. So it's a bit opinionated for building a full stack application using these tools. It's available in early edition from Manning right now. There's also a free 3-chapter excerpt that's sponsored by Neo4j that you can download at grandstack.io/ebook. So if you want to see some more in-depth content about some of the things we'll talk about today, that's a good resource. Okay, so what is Neo4j? What is a graph database? What are we talking about when we say graph database? So Neo4j is a database, a database management system. The main difference that you notice initially when using a graph database like Neo4j is the data model. So rather than tables or documents with graph databases like Neo4j, the data model is a graph. So nodes, these are the entities, relationships, connect them. Specifically, the data model that Neo4j uses is called the property graph data model. We store properties or the attributes on nodes and relationships. With Neo4j, we use a query language called Cypher to interact with the database. You can see an example on the screen there in kind of the upper right. And Cypher is all about graph pattern matching. So we draw these sort of ASCII art notation graph patterns. And you can see here in the example, we're saying match on an address node. So the parentheses, that indicates a node. And then you can see we have this incoming registered address relationship that we're drawing as kind of like an arrow. So that pattern says find an address where the address property contains New York, and then traverse out to find officers that have a registered address in New York. And then from those officers, find the entities that they're connected to. This query comes from the Panama Papers data set, which is a investigative journalism project. That team, the ICIJ, that analyzed the Panama Papers data, used Neo4j to keep track of exactly this thing. So offshore legal entities and officers connected to them. What else? The other interesting things in the Neo4j ecosystem are things like graph analytics. So representing your data as a graph, that means that there are lots of interesting algorithms, things like PageRank, community detection, things like this that you can do with graph data as well. And then graph visualization is also important. So being able to visualize your data and make sense of it as a graph. There's also Graph Database as a Service offering called Neo4j Aura, and then GraphQL Integration, which makes it easier to build GraphQL APIs. So there's sort of this ecosystem around Neo4j. You can think of it as sort of a graph platform that is interesting, or say different parts of it are interesting for different users. So if you're a data scientist or data analyst, you may be more interested in some of the graph analytics use cases and tooling. If you're building web applications, you're more interested in graph transactions and using the client drivers in different languages. And this is where the GraphQL integration comes in as well. So enabling you to build applications using a graph database is the idea there. Let's look at a really quick demo. So I have a data set loaded in Neo4j running locally. This tool, this is Neo4j Browser, which is like a query workbench for Neo4j. So it allows me to see what data that I have stored in the database and write Cypher queries and then visualize the results. So I can inspect my data. So let's say DB schema visualization, and I can see I have, let's tweak our style here. There we go. So this is
Whoa, that's cool.
yeah, this is sort of the meta model of the database represented as a graph. So we have data of users who are connected to reviews. Reviews are connected to businesses. So this is like a business reviews data set, which I totally just made up, but it's users writing reviews. Reviews are connected to businesses. Businesses are in a category. So that's how everything is connected. And we can write some queries here. So let's find a user named Will. You can see here we draw this sort of ASCII art representation of the node. And in parentheses, I'm saying find a node where the label, so a label is a way that we group nodes. You can think of it as kind of like a table from the relational world or a collection from the document database world. And then properties are represented within curly braces. So this says find a node with the label user and the name Will. So here's the Will node. I can traverse out from this node to find, okay, the reviews I've written, what businesses, what category are those businesses in. So I can work the data that way. I can also write more complex queries. So here, let's take a look at a more complex pattern. I'll zoom in a bit. So this says, find that user Will, and then traverse out from that node to find reviews that this user has written, and then what businesses are connected to those reviews. And so here's all of the reviews and businesses that this user has written. And again, I can traverse out from here to find other pieces of the graph. What are some common use cases for graph databases? Well, it's a natural way to represent our application data, which is nice, but there are some very specific use cases where graph databases really excel because they have different performance characteristics of other databases. So graph databases are optimized for these traversals from one node to another. And a common thing that we can do with these sort of traversals, zoom in just a little bit so we can see that query, is generate recommendation queries. So if I know the reviews that a user, or the businesses that a user has reviewed, what category they're in, I can recommend businesses in that same category to my user. That's a simplified version of the type of recommendations that we see in e-commerce. We can, of course, do much more complex things like collaborative filtering, where I'm looking at finding the most similar users. What are they reviewing? That might be a good recommendation, that kind of thing. But here, we've taken that pattern that we wrote last time. So find all the businesses that Will reviewed, now find what category they're in, and then find other businesses in that category that this user has not already written a review of, and score those according to the number of overlapping categories, and that might be a good recommendation for this user. So here's my 3 recommendations based on that graph query. Cool. So that's just a brief look at Neo4j and how we can interact with the database using Cypher and the browser and this Workbench tool. But most of the time, if we're building an application, we don't want to directly interact with the database tooling like this web browser. We don't necessarily want to expose the database to the world. We want to build some API layer so that our client application doesn't have to necessarily speak Cypher, but can use some common way to interface with the API. And that is where GraphQL comes in. So GraphQL, as you know, exposes your data as a graph to the application layer. So you are thinking of your application data as a graph. So when GraphQL was first open sourced several years ago, this was something very interesting for us at Neo4j, because we were wondering, okay, is there a use case for building GraphQL APIs backed by Neo4j? Is this something people are interested in doing? What sort of tooling could we build to make that process easier and smoother? And so right away, we started talking with some users, both of Neo4j who are interested in GraphQL and in the GraphQL community, and trying to figure out what made sense for some sort of database integration to build to make it easier to build GraphQL APIs backed by the Neo4j database. This eventually became what we now call Grand Stack, which is sort of this full stack framework for building applications. But the core of that is really this GraphQL Neo4j integration that we sort of, at a high level anyway, early on from talking to users, figured out what were the interesting features to build to solve some of the problems they have. So at a high level, things like reducing boilerplate. So if you've written GraphQL resolvers by hand, there's a lot of boilerplate data fetching code oftentimes that goes in there. So improving developer productivity, being able to build a functioning API more rapidly, but that also is extensible. So being able to add custom logic and make sure that it is performant as well. So those were the high level goals. And then specifically, what we wanted to do was support this idea of GraphQL first development, where you start with GraphQL type definitions, you start with the GraphQL schema, and that can then define the data model in the database. So rather than having to maintain two schemas, one for the API, one for the database, instead you can use GraphQL type definitions to define the data model in Neo4j. And because you're working with a graph database, there's almost this one-to-one mapping of the data model in GraphQL in the database. We also knew we needed to auto-generate all of the CRUD operations based on these type definitions. So you tell us the types and the fields, and then our integration adds all of the query and mutation fields that you need for all of the create, update, delete operations, and also adds things like ordering, pagination, complex filtering. So here in this example, I think we're looking at some movie data and filtering movies for comedy, zombie movies released after 1994, or animation movies starring Jesse Eisenberg. So you can construct some fairly complex filtering here. Out of the box, you have this sort of functionality without really writing any code at this point, other than GraphQL type definitions. So what about the data fetching layer? This, we wanted to solve as well. We didn't want developers to write a lot of data fetching code in resolvers. So our GraphQL integration is able to take an arbitrary GraphQL request and translate that into Cypher, so that query language we were looking at earlier with Neo4j browser. So then this means your resolvers are auto-generated and can take care of generating a single query to send to the database. This is important because this addresses some of the performance issues that you commonly have with GraphQL, like the N+1 query problem, where you're often sending multiple round trips to the data layer for a GraphQL request, because GraphQL is this very nested structure typically. So this also addresses that performance aspect by letting the database optimize the query and just making one request, so you don't have that network overhead of making multiple round trips to the database. So we talked about the generated CRUD operations that gives you basically the CRUD API for free, but what about custom logic? How do you add how do you add your own sort of business logic to this? And for this, we introduced what we call the Cipher schema directive. So schema directives in GraphQL allow you to define some custom logic that should happen server side. They're sort of GraphQL's built-in extension mechanism, I think. And what we've done here is allow you to define a Cipher query that can be arbitrarily complex. In this case, this is a query generating business recommendations. So very similar to the example query we looked at, but we can attach that to a field in GraphQL, and that then becomes a computed field. So now when we request the recommended field on the business node, we run this Cipher query to find similar businesses for this user. So that allows us to sort of extend the functionality of GraphQL using the power of Cipher for custom logic. There are a few implementations of this integration. One, Neo4j GraphQL JS, which is targeted for Node.js GraphQL applications. It works with any of the JavaScript GraphQL server implementations, so like Apollo Server, Yoga, some of the Apollo Server Lambda as well. There's a Java version of this for Java GraphQL APIs. And then a database plugin as well, so you can actually serve the GraphQL API from the database itself. The documentation and examples for all this are on the grandstack.io site. So what we're talking about here, if we look at Neo4j GraphQL JS, is it's an important distinction. We're not really talking about making the database speak GraphQL. GraphQL is not a database query language. And there are still cases where it makes sense to have this three-tier architecture, to have this API application that sits between the client and the database, where I can do things like enforce application authorization logic, caching, these sorts of things. So we're very much talking about a library that makes it easy to build this API layer that sits between the database and the client. If we look at the sort of the functionality of these GraphQL integrations, there's roughly two aspects. One is the schema augmentation, where we're adding the query mutation fields, adding input types, things like that. And then the GraphQL transpilation layer, where at query time, we're taking a GraphQL request, translating that to Cipher, and also handling that data fetching logic from the database. Let's take a look at an example that uses this Neo4j GraphQL JS library. So I have a code sandbox here that will fire up. And this is going to spin up a GraphQL API talking to some Neo4j instance that we have hosted in the cloud somewhere. So this is the connection string for that database. This is just a read-only user, so don't worry about my username and password being in there, just a demo. So if we look at the code for this, we're pulling in this make augmented schema function from the Neo4j GraphQL JS package. We're pulling in Apollo server, and we're pulling in the Neo4j JavaScript driver, and then some helper utilities. So the first thing we do is read our type definitions from the schema.graphql file, which is here. So here we've defined GraphQL type definitions for user, reviews, businesses, categories. So similar data model to what we were looking at in Neo4j. And then we pass those type definitions to this make augmented schema function. And that gives us a GraphQL executable schema object that we can then serve with Apollo server. We also create a connection to the database, this database driver instance, and we inject that into the context object so that this driver instance is then available in the GraphQL resolvers. But what resolvers, I guess you might say. So notice that we didn't write any resolver functions when we generated our schema. We just passed in our type defs. And that's what this make augmented schema export from the Neo4j GraphQL JS package is taking care of. It's generating the resolvers for us based on our GraphQL schema. So if we go to GraphQL Playground, let's open this in another tab. And here, let's start off with a simple query. Just find businesses and their name. There we go. So we come back with a list of businesses. We can add address and so on. And if we look at Code Sandbox, in the console, we can see here the generated Cypher query that's being generated. So here, if we're requesting to find businesses, name, address, let's add categories. We can see at query time, that query is being generated to find just the data that we're looking for, traversing Neo4j to find that data. We can also, like we said, add custom logic with this Cypher directive field. So here we have this recommended field. It is bound to a Cypher query that's finding similar businesses based on users that have reviewed it. So find all the users that have reviewed this business. What other businesses are those same users reviewing? That's a good indication of a recommendation for a business you might be interested in if you're interested in this business. So then I can add that recommended field now to our selection set. And so this is saying if you like Missoula Public Library, you might like Ninja Mike's, which is just a couple blocks away from there. And if we look at our generated query, we can see now that that recommended query is a bit hard to read because we're in the console here, but this this query that we've now attached to our recommended field runs as a subquery with our generated Cypher query along with the other fields that we requested. So still just one round trip to the database, which is pretty cool, I think.
That's interesting. And if that,
yeah.
Can you go back to the code really quick so we can see where the Cypher goes in? So that's pretty neat. There, it looks like you have a Cypher directive with the statement.
Yeah, exactly. And this can be any
cool.
Any arbitrary Cypher statement with whatever sort of logic we want to add. And we can do this on at the field level. We can also do this for custom mutations and query fields as well. So if we have a special way that we want to create data and instead of the generated mutations, we can do that. If we want to do something like use a full text index or something like that for fuzzy matching, we can do that on query fields as well.
So we have a question right here for you, and I know that I don't want to interrupt, but since we're talking about this right at this point, I feel like it's a good point. So the question is there a reason why it's translated into Cypher? And if you wouldn't mind just taking a second to let us know like the value of using Cypher within your GraphQL schema here, that'd be great.
Yeah, so I guess there's sort of a high-level reason that we translate GraphQL into Cypher, and that is, that GraphQL is not really a database query language, so we can't just send GraphQL to the database directly to fetch data from the database. And with Neo4j, we use this query language called Cypher. The benefit that you have there is very easily being able to express this idea of what in a relational database you would call a join or a traversal in graph parlance, which is sort of traversing from one node to another node. So in Cypher, that can be expressed just with this sort of simple ASCII art pattern. And something like SQL, you have to write a join statement to do that. It's a bit more complex, both at the query language level and also at the actual data store level. So we also don't want to just expose our database to the world and say, the client can create its own arbitrary Cypher to send to the database to find business recommendations, right? So we want to encapsulate that logic in our GraphQL API. So being able to attach these Cypher statements at the schema level allows us to take that custom functionality, attach that in our GraphQL server layer, and then that implementation is not exposed to the client, right? So if I'm a consumer of this API, to me, recommended is just another field that returns a list of business objects. I don't know that there's this Cypher query that's bound to this field. GraphQL schema directives are not currently exposed through introspection. So I can't introspect this API and see that there's this Cypher directive here. So anyway, so that's nice. That fact that you can't introspect a GraphQL API to see the schema directives also means that it's nice to be able to express some of your authorization rules in schema directives. So you wouldn't necessarily want to expose the authorization rules for your API to anyone, and it's a common pattern, and we use this in the Neo4j GraphQL integrations to add authorization rules as schema directives as well. Anyway, sorry, a bit of a rambling answer, but that's
great.
My thoughts on that. Cool. So that is a little look at how we use the Neo4j GraphQL JS integration. I want to talk a little bit about how we build that integration, and this is how a lot of GraphQL database integrations are built, and that is making use of what's called the resolve info object. So every resolver is passed this object called resolve info that contains a whole bunch of information about the GraphQL schema and the current GraphQL query that's being resolved. So it has a representation of the entire schema. It has an AST, that's abstract syntax tree of the current GraphQL query. Those are the most important things that we're interested in. You can see you also have the value of the GraphQL variables, the fields that have been traversed so far to get to the resolver that's currently been called. So all of this is in this GraphQL resolve info object, and we can inspect that object to find basically the nested selection set of the query. And this is important because once we have that, then from the root resolver, so in the case of a query operation, we can generate a single database query to resolve that entire nested selection set in one database query. And we also use this to implement that Cypher schema directive, which I'll talk about in a second. Right, so that's the idea, is we go from the resolve info object, inspect the query AST, find what the nested selection set is, and then iterate through that object to build up this database query. And you can apply this logic to Cypher, to SQL, or to other database query languages. Cypher, though, has a nice feature called a map projection, which allows us to shape the return structure of the database query to match exactly the selection set in GraphQL. So just like in GraphQL, where you're only returning the fields that have been requested in the selection set, we can do that in Cypher as well and return an object basically that matches exactly the data that our GraphQL server expects to be able to resolve the GraphQL request. We can also inspect which fields have these Cypher directives on them, so that when we are generating the query, we know to look for what is in the statement argument in the Cypher schema directive, and rather than try to fetch that field directly from the database, we basically just inject the user-defined Cypher query here as a subquery. So then that becomes part of the overall generated query. And this example was looking at, for a conference, recommended sessions. So similar to our business idea, if you're interested in this session, here are other sessions you might be interested in. This is kind of non-standard, I don't want to say weird, a non-standard way of implementing schema directives, I guess. It's useful if you are using the schema directive as sort of storing metadata, essentially. It's not the standard way of implementing schema directives. You might use the schema directive visitor from GraphQL tools to build schema directives. And this is what we use for building those authorization schema directives that I mentioned. So being able to add authorization rules using a schema directive to define what users should have access to what information and operations, essentially. If you're interested in this, I gave a talk at GraphQL Summit last year that dives into this in a bit more detail. So the link to that video is here. I think I also wrote a blog post, which I can link here as well, that goes into this in a bit more detail. Okay, so I thought we were going to be talking about low-code GraphQL. We've seen a lot of code so far. So what's going on here? What's the scam? Well, I think that low code is this buzzword that we hear a lot recently. And in my mind, there's really this spectrum of low code is the way I think about it. Like at the end of the day, developers don't really care about buzzwords. Like they're more interested in solving problems. So I like to think of low code as anything that solves my problem that involves me writing less code as a developer. So I think of it as this spectrum of low code that is anything from like libraries, packages, integrations like Neo4j GraphQL JS. That's low code in the sense that, well, I don't have to write resolvers and I can just sort of attach Cypher to my schema and add custom logic. So that's less code than like writing those resolvers by hand and reducing boilerplate. Then there's things like CLIs. So one thing I haven't talked about yet are some of the CLIs that are available, like Create GrandStack app, which provisions a full stack application, the GrandStack CLI, which has more utility functions. And then at the other end of the spectrum are UI-driven tools, which we'll talk about in a second, like GraphQL Architect, which allows us to build, query, and deploy GraphQL APIs without writing any code other than GraphQL type definitions. So that's how I think of things as kind of this low-code spectrum. Since I mentioned the CLIs, talk a little bit about that, or about two of those CLIs. One is the Create GrandStack app, which is great for provisioning the skeleton of a full stack GrandStack application. And then the GrandStack CLI, which allows us to do things like infer the type definitions from an existing database and generate those. I think we have a screen cap here of using Create GrandStack app, maybe. But if you've used Create React app, it's a similar idea, or if you use Create Next app, similar idea where you run this command and maybe we'll skip our screencast here. Similar idea, where you run this command, answer a couple of interactive questions. Do you want to provision a database? Do you have an existing database? What are the credentials? That sort of thing, and provisions out your application for you. And then the GrandStack CLI, which is more of like a utility CLI that I can point at a database, generate type definitions, point at a database, start a GraphQL API, assert the schema for the API, these sorts of things. And then built on top of those CLIs, we have GraphQL Architect, which is sort of a plugin for Neo4j Desktop that allows us to build, query, and deploy GraphQL APIs. So we'll take just a really quick look at this tool. So this is Neo4j Desktop. This is like the mission control, I guess, for Neo4j. So it allows me to download Neo4j databases, to point these projects at remote databases that I have hosted somewhere. But it also has the ability for running what we call graph apps, which are really like plugins for Neo4j desktop. So single page apps that allow me to interact with Neo4j databases. So the Neo4j browser, where I was writing Cypher queries and visualizing the results, that's a graph app. But another one that I'm going to launch now is GraphQL Architect. And GraphQL Architect, the idea here is when I point it at a database, it inspects the data model of the database and generates GraphQL type definitions that define a GraphQL API for the data in this database. So it immediately detected that I have this business reviews data set, and it gave me a user type, a review type, category, business, what are the fields on it, how are those fields connected by relationships. So I can just click start to start a GraphQL API locally, and then switch over to graphical. I can see here are all the query fields that have been added for me, and just immediately start querying the database. So this is similar to what we saw with that code sandbox example. And then I can add computed fields here. So similar to what we were doing with adding those Cypher directive fields, hit restart, and then those fields are available. So have a nice low-code iterative development process where I don't have to worry about, okay, what is the actual like Node.js JavaScript code to define and build this GraphQL server? Everything is driven from these GraphQL type definitions. And then when I want to deploy this somewhere, currently this can export to GitHub essentially. So I have this synced with a GitHub repo. As I make a change, it makes a commit to the GitHub repo with a change in the schema file, which I can then hook into something like Netlify or Vercel to trigger a deployment of my API. And that is available at install.graphapp.io, which also has a whole bunch of these other interesting graph apps for Neo4j that I can install as well. Cool. So that is pretty much all that I have today. I'll mention just a couple of resources if you're interested in learning more about this. Grandstack.io is the site that has a lot of documentation and tutorials, some more information on a lot of the things I talked about today. I mentioned the book that I've been writing that's available now in early release, and the free excerpt that is available at grandstack.io/ebook. I've started doing live streams more recently, which has been kind of fun for me on the Neo4j Twitch channel. We've gone through the process of building a few GrandStack applications from scratch. So we built a real estate search application. I think we're going to start a podcast application this week. So it's every Thursday at 2 p.m. Pacific time. So if you're interested in learning more about using GraphQL and Neo4j, that's a good resource as well. You can watch me kind of fumble along building an application. And then, like I said, Twitter is probably the best place to get a hold of me.
Cool. You guys have been really busy over there. That was a lot of neat stuff. I particularly like the visualizer. The graph visualizer, to me, I'm just like, it looks like an incredible tool for just teaching what graphs are and whatnot. So I was really excited about that. Sweet. Well, does anybody have any questions for William? I can give us a couple seconds for that. And if not, I guess that will just bring us to an end here. So we want to thank you for attending the GraphQL Meetup. Again, you can find me on Twitter at MoonTahoe. Eve is on Twitter at Eve Porcello. You can also look us up at moonhighway.com. And at Moon Highway, we teach JavaScript to software engineers of all skill levels. So we build curriculums, we have classes, and we teach in the classroom too. So if you want to get in touch with us on any of that, please feel free to reach out. Yeah, and that brings us to the end of the day. Let's see here. So we do have a question in the chat. And it says that the GraphQL type system validates all input relative to the schema, and the generated Cypher queries are always parameterized. Okay, it looks like I guess we're answering a question from earlier in the chat here. So I just read that answer from the chat. So I will leave the chat up here for a few minutes if you want to continue to chat and ask any questions about Grand Stacked or Neo4j. But that brings us to a conclusion of this meetup. Thank you so much, William. A lot of good information.
Thanks for organizing. Thanks for having me on. And thanks everyone for joining.
Great. Thank you.